So we're going to discuss the vocabulary involved with linear equations. And there's going to be a lot of new stuff. Some of it's stuff we've built on, like when we talk about constants. Constants a number that never changes, right? We're going to talk about some of that. We're going to talk about proportionality. You guys know it as ratios. So a ratio is proportional because the right side is the same as the left side. 1/2 is proportional to 2/4 because they're the same thing. It's both of them are just another way to write 1/2, right? So let's go into this stuff. So the first one is a constant k in direct and inverse variation equations. This one's probably the longest one. It's called the constant of proportionality. Somebody's got their Quizlet open.
Why does someone have
No, she's just smart.
The constant of proportionality. And it pretty much tells you what it is. We call it K. And I'm going to tell you this. And the equation would be y equals kx. That is the proportional relationship, meaning that it always starts at 0. The line, if we wrote this like we did yesterday on the calculator, a line where y equals kx will always go through 0, 0. It'll always go through the origin. Or, as I like to call it, the Wookiee zone.
That's weird.
Because 0, 0 is, if you sound it out as
What?
so every time you create a proportional line, you will kill a Wookiee.
What happened?
Star Wars jokes.
Yes.
Okay, a linear relationship between two variables, x and y, that can be written in the form y equals kx. We just did that above, right? Where k is a non-zero constant. And it set it up here, it talked about inverse. This is called direct variation. And it's direct because it starts from 0. X and y always rise at the same rate throughout direct variation. And you might use it for something like an equation for how much do I get paid per hour. Y would be your total pay. K would be a constant. Let's say $4.50 an hour. And then X would be how many hours you worked. You work 2 hours, you get $9.
Wow.
Because it's 2 times $4.50, right?
That's almost what I mean.
Is that almost what you make? It happens at this young age. I used to
get
get
screwed for my mind.
Yeah, used to get paid stupidly little too. So direct variation means it's a ratio, and it's very common with money because you get paid per hour early on. Ratios that are the same comparison, we call them equivalent ratios. Let's see if I can spell. So an equivalent ratio would be 1/2 equals 2/4. They're the same ratio, aren't they? Ratio is a fancy word for fraction. Does that make sense? As you're working to get ahead there, Felicity, remember you're missing some of what I'm doing on the board because you're writing so fast that you're not catching. Did you write what I just wrote? I'm just letting you know. Yeah, you fill it in fast, but you're missing the points. So an equation whose solutions form a straight line on a coordinate plane. A coordinate plane is your xy plane, right?
Or what?
Your xy plane. You've got an x that goes left to right and a y that goes up and down.
I thought you said XY.
No,
She did. I mean, he did.
I don't have any xy's.
No, but ex-girlfriend take it.
Nope, I got a couple of those. This is called a linear equation because it makes a line. In fact, basically, equation and line are in the definition, right? So it pretty much gives you what it is. It's a linear equation. It makes a line. A pair of numbers that can be used to locate a point on a plane, and they're usually written this way. They're usually written as x comma y, which could be something like 4 comma 3. That would be the point. X would be 4, and Y would be 3. We call them an ordered pair.
Whoa. Big word.
Big words. Bigger paychecks. The bigger the word, the bigger the paycheck.
I wish.
The bigger the acronym, the less important you are.
Really? What's that?
The President of the United States, he doesn't really have an act. Pontus. Okay?
He gets paid a lot.
Not as much
really.
as you think.
Yeah, not really.
Can't you only get paid 300?
An equation that states that two ratios are equivalent. An equation that states that two ratios are equivalent. We call that a proportion. If you think about it, this is the exact same definition for equivalent ratios, isn't it? They really are. So 3/6 equals 1/2. That's a proportion. What's 3/6 simplified? 1/2. So they're the same ratio, aren't they?
Si, senor.
Just written differently.
Why? How are they different?
Well, they're just written different. They're the same ratio.
Yeah, see,
They are a proportion.
and one's half of 2.
Now, where that gets important, remember yesterday we did like 10 over 5 equals 20 over x? Do you remember that yesterday? So what that says is this ratio is equivalent to this ratio, or they're proportional.
X is 10.
Very good. X would be 10 in that case. Because you said, hey, to get there it's times 2, so times 2, right? You used one of your tools out of the toolbox. Congratulations. A relationship between two quantities in which the ratio of one quantity to the other quantity is constant. This is a proportional relationship. We're going to do proportional relations, and the term proportional relationship and direct variation are really the same thing. A proportional relationship always starts at 0. The ratio between the two quantities is exactly the same. A proportional relationship is the best kind of relationship you can have as you grow up. That means both of you give the same.
You did. Good luck.
Yeah, I'm just telling you. But you can use that. So, a ratio that compares two quantities measured in different units. Think about miles per gallon. That's two quantities, right? That's miles and gallons. We call that a rate. Your car might get 18 miles per gallon. So it's actually 2, and it would be written as 18 miles over gallons, or miles per gallon. Does that make sense so far? Very common. It's a rate. You get paid $10 per hour. That's a rate. The lawyer charges you $525 per hour. That's a rate.
It's a lot.
It's a little.
Yeah, it's not.
Lawyers are stupidly expensive by the hour.
Who?
Lawyers.
Let me tell you something. You ain't gonna have it for 1 hour either. So you ain't gonna have it for 1 hour either.
Yeah, they will charge you up. So, a ratio that compares the amount of change in a dependent variable to the amount of change in an independent variable. So, this is called a rate of change. So an independent variable is not affected. If I did 18 miles per gallon,
That's not bad.
it's not good. Okay.
Not the best.
So I won this.
So that is 18 miles per 1 gallon, right? So that miles per gallon can become an independent variable. It's not affected. But if you drove 30 miles, the resulting amount of gas is a dependent variable because it's depending on that first variable and what it makes it. It changes. Think about independent variables basically being a continuous or constant type number, whereas a dependent variable changes based on actions taken upon it. Does that make sense? It's dependent on somebody, whereas independent, you do your own thing. All right, here we get to one. A measure of the steepness of a line on a graph, the rise divided by the run. We call this M. We went over that yesterday. What's M?
A mountain. Oh wait, a slope.
A slope, because mountains have slopes. It's a slope. So M equals rise over run, or Y over X. We're going to see it a bunch of different ways. So we're gonna find slope in several ways. I will tell you that M and K are the same thing. K is used in a proportional relationship, and M is used in a non-proportional relationship. K is used in direct variation, and M is used in y-intercept format. Why do they have two variables that mean the same thing? Because two mathematicians found these different equations and each set it down. Pretty much it was punishment to middle schoolers, because they could have made both M and that would have made it too easy for you guys. So now they have an M and a K. Does that make sense a little? M and K really fill the same purpose. They really deal with the slope of the line. A linear equation written in the form of y equals mx plus b, where m represents the slope and b represents the y-intercept. It's called slope-intercept form. Slope-intercept form. And it really is no more fancy than it talks about the slope and it talks about the y-intercept. Thereby, slope-intercept form.
Whoa, dude.
When you hit algebra, they're going to show you how to write the same equation two other ways. But all they're doing is moving stuff left and right. There's no change except that they move stuff around in the equation. They still do the same thing the left side as they do the right side. Okay? We also call this commonly the y-intercept form. And the reason being is the real focus is on getting that y-intercept all by itself. That b. You got to keep b's alone, man, or they sting you.
Not necessarily.
There's always going to be one in a crowd who says no.
That would be ordinary.
So, a set of equations that have the same variables. So they might have x and y as their variables. We call them a system of equations. And we might do something like, say, Caitlin and Aaliyah decide to go to the movie, and tickets cost $4.50 a piece. They have a total of $20 to spend. How much soda can they buy if sodas cost $1 a piece based on it? We could write two equations and solve that.
But we need popcorn too and candy.
Sorry, it's not in the equation.
Or you can
Okay,
give
but
another person.
You don't get any because it's not in the equation.
It's only 5 Cokes.
Yeah, so we have room for popcorn. Candy.
Last one, a rate in which the second quantity as comparison is 1 unit. Go ahead.
Unit rate.
Unit rate. And I talked about one before. I talked about 18 miles per gallon, right?
Yeah.
What that really equals is 18 miles per 1 gallon, right? Miles. That's really what I said. That's a unit rate. 18 miles per gallon. 1 sucker per student.
That sucks.
Right now.
That's a unit rate, isn't it?
Yes.
Yeah.
If I said 1 sucker per every 3 students, would it be a unit rate?
Yeah. I mean, technically,
That-
it would.
Yes, but you'd have to word it. It'd be 3 suckers, or it'd be 3 students per 1 sucker, and then it would be a unit rate, right?
So can you hear that suckers now?
Any question on vocation or
Okay.
equation vocabulary? I tried to make a new word.
Vocation.
Vocation. So it's vocabulary and equations stuck together. We're going to talk about linear equations a lot. Y equals mx plus b and y equals kx over and over and over again. These are the 2 most important things you have in your toolbox right now. There are a ton of ways to solve it. I'm going to show you many different, and not all. I'm going to tell you that if your method gets you there 100% of the time, it's a good method.
Thank you.
If your method gets you there only 60% of the time, throw it to the curb and never use it again.
How about 99?
Run it over a couple times.
No. Not if it's not 100% of the time, don't use that method. This is generally where I get a lot of creative students who will introduce new things. They say, I tried this and it worked. Well, it worked on that equation, but let's apply it to another one. If it doesn't work on every equation all the time, it's not a good method. Does that make sense? So you guys are going to have to be very methodical. You're going to have to learn what slope is, and that it's m, and what y-intercept is, that it's b. And then x and y are an ordered pair. And they're always coordinates on the graph. Does that make sense?
Yes.
All right.